Hello, I'm Chen Haotian, come from Xuzhou University of Technology. Today, I will talk about our research, pollen recognition and classification method based on local binary pattern. Let's talk about the introduction first. At present, pollen classification and identification mainly rely on manual operation under microscope. Compared with the classification and the identification of pollen by computer, this method is less efficient. Many scholars have conducted in-depth research on pollen image recognition and obtained specific research results. Most texture feature extraction methods have specific recognition ability for some unique pollen textures. However, they are not general enough to be applied to all pollen image recognition. To solve the above problems, this paper proposes a pollen image recognition method based on local binary mode. Let's talk about the methods. Firstly, let's talk about the traditional local binary pattern. This local binary pattern is defined in the neighborhood of a 3+3 matrix. The target image is convolved with this matrix as a calculation template. The pixel value of each district of the center pixel is binarized with the center pixel as the threshold. The position of the center pixel is more significant than code 1. Otherwise, it is coded to form a local binary numerical matrix. Obtain the values in the matrix clockwise from a given point to obtain a binary string and convert the string to decimal. Secondly, let's talk about the extended local binary pattern. To adapt to the texture features of different scales and meet the grain scale and rotation invariance requirements, Ojala made improvements, extending the 3+3 neighborhood to any neighborhood and replacing the square with the circular area. Finally, let's talk about the uniform local binary pattern. The LBP feature already has grain scale and illumination invariance, but not rotation invariance. In order to realize rotation invariance, researchers proposed rotation invariance LBP feature. The main idea is rife. First, continuously rotate the LBP features in the circular neighborhood. Obtain a series of LBP eigenvalues according to the selection, and select the LBP features with the smallest LBP eigenvalues from these LBP eigenvalues as the center pixel. Then let's talk about experimental results. To verify the method's effectiveness, the pollen image of the experiment in this paper, we use the confocal dataset. It currently includes most of the image data of pollen detected in the air. The dataset uses a laser scanning confocal microscope to ensure data concentration. In this paper, SVM is used to calculate the similarity between features. 20% of each type of pollen is selected as a training sample, and the rest are used as the experimental sample. Before calculating the LBP feature value, the original image needs to be interpolated or downsampled according to the resolution of the original image. And then image filtering and other pre-processing are performed to improve the image quality. In the experiment, the accuracy rate, correct recognition rate (CRR), recall rate (RR), and recognition time (RT) verify the performance of the experiment. Let's focus on this table. This table shows the classification and recognition performance of six pollen images. From the experimental results, it can be seen that the recognition rate on the confocal image database is generally higher. The correct recognition rate can reach more than 19%, and the recall rate can reach 95%. For pollen images with relatively poor quality, such as jungulans, it can also achieve about 80%. From the recognition results, it can be concluded that the recognition performance of pollen will be affected by the quality of pollen to a certain extent. The wrong classification is mainly caused by the noise or the unclear sampling. The experimental results show that the LBP is not the spatial geometric transformation of pollen images has good invariance. Let's focus on this table, the table 2. We compare the experimental results with the WT feature descriptor, GSLT feature descriptor, and MLFD feature descriptor. Because different types of pollen have various internal texture features, such as thorns, rods, holes, nades. Depending on the type of pollen, this feature will become more evident in the three-dimensional pollen image. Hence, this article's LBP texture feature extraction has more vital discrimination ability, better recognition effect, and higher recognition efficiency. And it can be seen from the experimental results that compared with the other three methods, the average recognition rate can reach 88.46%, 9.9% higher than other similar methods on average. It is also superior to most methods in terms of computational efficiency. For example, compared with WT, the correct recognition rate of the method provided in this article is about 40.96% higher. Compared with GSLT, the method in this article has significantly reduced time and space complexity and improved recognition rate in the process of extracting 3D features. Compared with MLFD, the correct recognition rate of the method provided in this article is 2.52% higher. Experiments show that this method has a higher recognition rate and good geometric invariance than other texture feature extraction methods and is suitable for actual pollen classification and recognition. In all, we propose an automatic classification method for pollen images based on local binary patterns. This method is based on the low complexity LBP operator. It directly extracts the features of the image in the spatial domain, avoiding the processing of transforming the image to the frequency domain. The calculation step has high operating efficiency. This paper combines the green change direction of the pollen image with the texture feature to extract the image feature with relatively low dimensionality and a reasonable recognition rate and obtain in the experiment high pollen recognition rate. However, for partially occluded pollen images, especially pollen images in internal slice images of pollen images with a fuzzy texture, experimental analysis shows that the classification methods in this paper has strong pollen characteristics, representation ability, and distinguishability, and has high robustness to illumination, rotation, and position changes of pollen. So that's is my presentation for my paper. Thank you so much.